Hello everyone! Today we will be focusing on how to solve a question on chemical reaction engineering from a past year paper. We have chosen to do a theory question from 2011-2012 Semester 1 paper. The question will be as following. The liquid phase reaction A plus B producing R is a reversible and isothermic reaction. The initial concentrations of A, B, and R are 0.555 m, 1.22 m, and 0 m respectively. The equilibrium conversion of the limiting reactant is 86.8%. Part A. State a theory that is used to predict the effect of a change in operating conditions on chemical equilibrium. The theory used here to predict the effect was Le Chatelier's principle, which states that when a system in equilibrium is subjected to change in conditions, the equilibrium will tend to move in such a way as to minimize the change. Part B. What can be done to increase the conversion of reactant B at equilibrium? In order for this to occur, the equilibrium has to be shifted to the right. This can be done when the temperature of the system is decreased, when the pressure is increased provided that B is in gaseous state, or thirdly, concentration of A and B is increased. Part C. Explain the effect of catalyst on chemical equilibrium. It provides the reaction an alternative path without affecting the equilibrium of reactant and product. It can either increase or decrease the activation energy. Part D. Calculate the equilibrium concentrations of A, B, and R. The initial concentrations of A, B, and R were given as follows. As you can see, A is actually the limiting reactant. Since the equilibrium conversion of the limiting reactant was given as 86.8%, we can then calculate the concentration of A during reaction, which is 0.48174. As 2 moles of B is required to react with A in order to produce R, multiplying 0.48174 twice will give the reaction concentration of B, which is 0.96348. In order to calculate the equilibrium concentrations of A, B, and R, subtract the reaction from initial value. Thus, equilibrium concentrations of A, B, and R is 0.0733 m, 0.257 m, and 0.482 respectively. Part E. Explain the differences between a chemical reaction process in steady-state condition and in equilibrium. The first difference would be, in equilibrium, the concentrations of components are being held constant because the reaction rates are equal in the forward and backward reaction. However, in steady state, only some components are kept constant because its synthesis rate and the consumption rate are equal. For this, the reactions need not necessarily be in equilibrium. Another difference would be, in equilibrium, there is no net change in the whole system, whereas in steady state, the reactants and products are changing. Only the intermediates is constant. With that, it will be the end of our video. Thank you for your kind attention. Do stay tuned as we will be coming back with a new video next week. Do continue to support us. Goodbye.